Thermostability is the quality of a substance to resist irreversible change in its chemical or physical structure, often by resisting decomposition or polymerization. At a high relative temperature, thermostable materials may be used industrially as fire retardants. A thermostable plastic, an uncommon and unconventional term, is likely to refer to a thermosetting plastic that cannot be reshaped when heated, than to a thermoplastic that can be remelted and recast. Thermostability also commonly refers to a protein resistant to change in its protein structure or due to applied heat. Thermostable proteins. Most life forms on Earth live at temperatures of less than 50 degrees Celsius, commonly from 15 to 50 degrees Celsius. Above this, thermal energy may cause the unfolding of the protein structure, where the activity of the protein is abolished in a condition understandably deleterious to continuing life functions. The denaturing of proteins in albumin from a clear, nearly colorless liquid to an opaque white, insoluble gel is a common example of this. Certain thermophilic life forms exist which can withstand temperatures above this, and have corresponding adaptations to preserve protein function at these temperatures. These can include altered bulk properties of the cell to stabilize all proteins, and specific changes to individual proteins. Examining homologous proteins present in these thermophiles and other organisms reveal only slight differences in the protein structure. One notable difference is the presence of extra hydrogen bonds in the thermophile's proteins, meaning that the protein structure is more resistant to unfolding. The presence of certain types of salt has been observed to alter thermostability in the proteins, indicating that salt bridges likely also play a role in thermostability. Other factors of protein thermostability are compactness of protein structure, oligomerization, and strength interaction between subunits. Thermostable enzymes such as Taq polymerase and pFUDNA polymerase are used in polymerase chain reactions where temperatures of 94 degrees Celsius or over are used to melt apart DNA strands. Another important group of thermostable enzymes are glycoside hydrolases. These enzymes are responsible for the degradation of the major fraction of biomass, the polysaccharides present in starch and lignocellulose. Thus, glycoside hydrolases are gaining great interest in biorefining applications in the future. Bioeconomy. Some examples are the production of monosaccharides for food applications as well as use as carbon source for microbial conversion in fuels. Ethanol. In chemical intermediates. Production of oligosaccharides for prebiotic applications and production of surfactants alkyl glycoside type. All of these processes often involve thermal treatments to facilitate the polysaccharide hydrolysis, hence give thermostable variants of glycoside hydrolases an important role in this context. Approaches to improve thermostability of proteins. Protein engineering can be used to enhance the thermostability of proteins. A number of site-directed and random mutagenesis techniques, in addition to directed evolution, have been used to increase the thermostability of target proteins. Comparative methods have been used to increase the stability of mesophilic proteins based on comparison to thermophilic homologs. Additionally, analysis of the protein unfolding by molecular dynamics can be used to understand the process of unfolding and then design stabilizing mutations. Rational protein engineering for increasing protein thermostability includes mutations which truncate loops, increase salt bridges or hydrogen bonds, introduce disulfide bonds. In addition, ligand binding can increase the stability of the protein, particularly when purified. Thermostable toxins. Certain poisonous fungi contain thermostable toxins. such as amatoxin found in the death cap and autumn skullcap mushrooms and patulin from molds. Therefore, applying heat to these will not remove the toxicity and is of particular concern for food safety. See also thermophiles, Thermus thermophilus, Thermus aquaticus, Pyrococcus furiosus, thermostability of proteins.